Okay, so far we have done a lot of theory considering derivatives, limits, Bolzano-wise theories. But what's the point? Well, the point is to give you a formal introduction to calculus. Okay, and although might have done calculus in your previous education, it's very necessary that you know how these things are being computed, right? And you'll be introduced to advanced calculus. So in the next few sets of videos, you are just going to be solving multiple examples on calculus. Okay. So there is a simple rule. We'll take a rule and we take examples on that rule. There's a simple rule I want you to see. So the rule goes like when you're asked to differentiate any constant times a function, right? You can bring the constant out and differentiate the function alone. Okay, as simple as that. And here's the proof of the rule, right? You can use the first principle theorem we discussed, but I don't think it's really necessary now. So for example, you are asked to differentiate the function 3x raised to the power 4. Let me work on my mouse. So you were supposed to work on 3x raised to the power 4, right? And you can go through the same procedure. So your function was 3x raised to the power 4. Now, you realize that this function is the x, which is actually the function. The 3 here is a constant, right? So what the rule is saying that when you're asked to find the differential, so d of 3x raised to the power 4 with respect to x, right? Just bring the 3 out and differentiate what is inside. Okay, now with the 3 outside, we can find the differential of x raised to the power 4, right? We know that it follows the general rule x raised to the power n, right? Where n here is 4. So this one, when I differentiate this one, I get n multiplying x raised to the power n minus 1. So it means that this one, if I differentiate this one, I get what? 4 multiplying 4x raised to the power 4 minus 1, which will give me 3 times 4x, x raised to the power 4 minus 1 is what? 4x cubed. Then now this is a constant, you can multiply this constant, so I'll get 12. So the answer will be what? 12x raised to the power 3, right? As simple as that. The procedure wasn't so complicated. Okay, and that's what is 12x cubed. Now, the second example gives you to differentiate minus x. You go to the same procedure. Here the constant is minus 1, and you just bring it out. You differentiate x. When you differentiate x, you get 1, right? Because you will now be doing x raised to the power. You'll now be doing x raised to the power 1, right? Instead of x raised to the power 4. So you'll be taking d of x raised to the power 1 of x, right? So you get 1 multiplying x to the power 1 minus 1 as your differential, which is what? X raised to the power 0. And x raised to the power 0 is the same as 1 from indices. So that's what you see over there. Okay. Now that's just one rule. So from here on, anytime you see a function product a constant multiplying the function, you should be able to do it easily. Alright. Now we take the next set of derivatives, and this one is called the sum rule. And it says that if you have a function such that it's the sum of two or more functions, right? Then you can go ahead and differentiate the individual function. Let's see an example, and the proof is there, but we'll not be going through. And I mean, if it's also the difference, it's also the same procedure. It's just the sign which changes. So for example, each of these ones is a function. X raised to the power 8 is a function. 12x raised to the power 5 is a function. Minus 4x raised to the power 4 is a function, and continues. So when you have a very long expression as this, right, what you do is that you take it in bits. So first take x raised to the power 8, we differentiate, okay, and that's what you see. 12x raised to the power 5, we do the differential. 4x raised to the power 4, we do the differential individually, right? And then do the differential where we have a constant, we bring the constant out and differentiate the function alone. And go ahead, and I mean, it's just the procedure. So the 8 multiplies by now you have what? Raised to the power 7 because the power reduced by 1 according to the power rule. And your simplification will lead you to this, right? Hope it was easy. Now, that's the step-by-step procedure, right? And it doesn't change whether your function is this. But you see, in as much as we are asking you for differentials, there are other questions which you could be asked. For example, the whole point of derivatives is to show how the function changes, right? How whilst we vary the values of x. So for example, let's take this function. Let's assume we have a function which is drawn like this. So by now I'm aware of this, that you are aware of this function x squared, right? The graph is that as as you keep on increasing the values of x from negative to positive, the function behaves weirdly, right? So you realize that first the function decreases in value, right? Then now it increases in value again, okay? And it reaches a 0 point. Now, what differentiation of this function will give you is, when you differentiate this function, you get 2x, right? Now plot that graph. Realize that that graph is what? A line, right? A straight line through the origin with a gradient of 2, right? What this function, what this differential graph tells you is how this function changes with increasing values of x. So it tells you, like for instance, when you initially start decreasing the value of x, so this is the x-axis, so initially start decreasing the value of x, right? The value of y starts increasing, okay? We are on the positive axis, right? Until you come and get to the origin, until you come to get to the origin. That is when you start increasing the value of x, the value of y also increase, right? And that's what the differential is supposed to tell you. It's supposed to tell you how the function is changing, okay? Now, usually, these points where there is no change, right, even though we are inputting an x value, is of necessity, and it's usually called a tangent point, okay? And that's what you're asked. So they said you are asked to find where the tangents occur in the curve, okay? So all you have to do is, when you see this question, is first differentiate, okay? When you hear tangent, first differentiate your curve. Now I'm very certain that you can do the differential. Now when you differentiate, you come and get what? 4x cubed minus 12x. So our differential was 4x cubed minus 12x. 4x cubed minus 12x. Right, that's our differential. Now, what did we realize about our differential? At that point, the function is 0. Okay, so it means that if you want to find the tangent at that point, at the point of the tangent, then it means that we have to set the whole differential to 0. So we'll get 4x cubed minus 12x is equal to 0. And probably you've solved a lot of these equations. But let's just go through for the sake of being thorough. Now, I can solve this in several ways. So you let me factorize x out. So when I factorize x out, I get x out 4x squared minus 12. It's equal to 0. Okay. Then I can say x is equal to 0 as one solution, or 4x squared minus 12 equals 0. Right, now x equal to 0, we know that that's the final answer, but this one we have to simplify. So 4x squared minus 12 is the same as 4x is equal to 12. That's bringing 12 to the other side. We can divide both sides by 4, which will give us x squared is equal to what? 3. We square root both sides and we get answer of what? Plus or minus 3. Square root of 3. Now, These are the values of x at the point of tangency, right? So what does it tell you about the curve? Well, it tells you that there are three static points on the curve. That is the point where y does not change when you change x, right? One is at point 0, one is at what? Positive root 3 and negative root 3. And now let's see the graph of the curve. You realize that it's very interesting. So this is the graph of the differential curve, okay? This is the graph of the, sorry, the graph of the original curve. Now, so the graph of the x raised to the power 4 that you see, but see, it has three stationary points, three of them, okay, and the x values there are what? Minus root 3, positive root 3, 0. Do you remember that's the same solution we got? 0 plus or minus root 3, okay. Now, this shows you the point of tangents, and I mean, once you have the x value, you just put it here, you can solve for y, so we'll not be doing that. But what we are trying to tell you is that the differential gives a definition for the curve, or it helps us to define the curve. And in more complicated maths, you'll be doing more advanced differential, right? But the differential is supposed to give you a description of the curve, right? Even before you draw it, okay? Yes, and that's the power of it, and it's very beautiful. So now we'll take our last rule, and this is called a product rule. It says that if you have a function which is a product of two functions, okay, so you have f of x, g of x multiplying, right? Like you can conceptually see that, oh, this is a product of two functions. For example, you have a function like x squared sine of x. You realize that it's a multiplication between x squared and sine of x. So those are the two functions. Now, the product rule shows you how to differentiate it from here. It says take the very first function, right? Multiply by the differential of the second, plus take the second function, multiply by the differential of the first. As simple as that. Okay, so let's take an example. We'll not look at the proof. So for example, this is what 6x cubed multiplying 7x raised to the power 4. Now, because we are starting afresh, let's take very basic example. Although someone can just simplify as 42x raised to the power 7. This whole expression, but let's take very basic example. So our example was 6x cubed 6x cubed multiplying now according to the product rule, it says take the first one multiplied by the differential of the second. The first one is 6x, so we take 6x times the differential of the second. When we differentiate this alone, what do we get? Well, we'll get 4 times 7x, right, which is 28x. So 28x cubed plus the rule says take the second one multiply by the differential of the first. So the second one is 7x raised to the power 4 times the differential of the first, which is what? 18x squared. I mean, by now you should be able to do this. The 3 comes down and multiply. So 6 times 3 is 18, and the power reduces by 1. Okay. Yes, just be a bit quick sometimes. You should be able to do this. Now, you can simplify by expanding the expression and all, right? So at the end of the day, realize that we get this final answer, okay? And this is called the product rule. Now, note, even though we did it this way, we could have simplified the function further, right? We could have said the function is the same as 42x raised to the power 7. We are correct. And now we can go ahead and differentiate and get 294, just like we did for here. We are very correct. It's right. Okay. But you see, we are only saying this because you have two polynomial functions multiplying. Now, sometimes you get a polynomial function and a trigonometric function or some transcendental function. And you realize that this will be very, very useful. Okay. So in our next set of meetings, we'll go ahead solving these and familiarizing ourselves with the rule. Go ahead, solve a lot of questions. And don't forget to like, share, and subscribe for these videos. Thank you very much.